Yeah, it was amazing. Um, I just completed the first part of the project actually here. Uh, Basically, it's basically an ETL pipeline, and yeah, for this project, I just used the crash not to crash dataset. This one is the dataset that I used. There are several reasons why I used. It has many several labels that we can use to see the prediction of each vehicle to be the prediction that shows that which vehicle is going to give us the crash detection as well. This dataset has several other uh, a lot of annotations in this dataset because it's a simulated the simulation dataset from GTA 5. So the GTA 5 gives a lot of annotations from its environment itself, from its data collection itself. So it was better in case better than real data. Maybe in the future we can use the real data, real data itself. Let me share the screen right now. Okay, yeah, this is basically the project um, behind this crash detection combination. It's already been um, explored, and I'm just giving my own way of implementation of this project. Just that's the thing, and I'm hoping to give much more improvement um, to this code in future. This is the official website, which contains the abstract, the videos, to the link to the videos and paper to it. Uh, it's from the several engineers or researchers from South Korea, and this is basically the data sets we have, like GTA crash and YouTube crash video. A YouTube crash video was from this YouTube channel.
Movie and a
This YouTube channel is basically recorded in a lot of crash situations in the real life, so we can train our model with real life data as well. So we can avoid the situation of data distribution shifts when we actually deploy our model into the real life. So there's a GTA crash dataset, and there is a YouTube crash dataset, and this is a test dataset from the YouTube crash, because we are going to test this dataset on a real world, so we need to be testing it on real world itself. The GTA crash dataset has seven labels. You can see that vehicle info, other vehicle infos as well as are given. So that's a very important thing. For the YouTube crash dataset, we don't have any kind of these labels. Just if this is going to hit or not. That's the only information, and few synthetic informations about the positions and all. That's all the things that we have, and then we can see several kind of videos from this data set here. Okay, just a minute. I'm going to share the entire screen. Yeah, yeah. So this dataset has several GTA 5 scenes where that crash that happens. You can see the crash happening scenes here. And from this we can understand the moment the crash happens, it stops. The recording stops. I don't know how can we avoid it from the uh, data exploration side. That's the next stage we are going to do. So you can see several kind of crash situations inside of this one. The reason why GTA Crash is very good data set is that it has a lot of situations that we actually encounter in real life, but there is still problem about the frames, the distribution shifts. We can use some kind of regularizers, stabilizers, or the data distribution shift prevention algorithms to actually solve this problem. Maybe maybe I will just use some kind of other real data to solve this problem as well in future. Just view some of the non-accident scenes as well. From this, you can understand there is no accident. Non-accident is fairly more easier to actually understand. And this one is amazing. Wow, that wow. This is also good. I mean, this data set is also good, but this is very fierce. I mean, the data set is not so much. Um, as you can see, there's only 122 clips, and each clip is only 20 frames, so that's very low. So we cannot actually rely on deep the computer vision algorithm based on this one. But as far as I had decided, I'm not going to use deep learning or machine learning at the very first moment. I'll try to solve this problem using our own pattern recognition task. Um, maybe it won't be possible, maybe, but this is a kind of understanding how should we actually approach any kind of computer vision problem here. So it's not always the best option to actually go for deep learning in the first step. Maybe there are cases where you don't have much time to actually implement. In cases where I have been participating in a 4-hour hackathons where we can't actually do a lot of experiments, but if we have a lot of teammates, we could do a lot of experiments and understand with the patterns inside of it and exploit those patterns using deep learning. And understanding the patterns is very important so we can exploit and design algorithms based on it, rather than you just use some kind of images and just go on to um, do the deep learning part. It's easier, but it's not the best way how engineers actually approach this problem. So it's always better to actually see how the values change in non-accident situations. So in this way, we can understand how and how can we um, how can we use it in our situation. That's very important. Um, to do this data set, I just downloaded this data set using this script. This script downloads the data set from the Google Drive because all of them were from the Google Drive. Here, you can see the code from all of these were from Google Drive. So I just take this ID and use gdown and download every single kind of data set. I don't have much space in my laptop right now, so I just did this entire ETL pipeline in Kaggle. And after downloading the dataset, we can use the ETL pipeline, which takes each one of these datasets and um, creates a new dataset called test images, train images, and the train.csv and test.csv. When we download this dataset and we are extract the files inside of it, it will be almost would be um, all of them would be in a JSON format and JPG format. It would be a continuous images. So I just organized it in a very pretty fashion here. Oh, sorry, I shouldn't have chosen the train images. This is going to take a long time. So I just couldn't handle all these images. You can see this is the video ID and this is the frame ID. So each video ID will have 20 frames. So this is so amazing, kind of splitting the data. So I do the ETL pipeline here. You can see it took like 16 minutes. That's why I couldn't actually That's why I couldn't actually do run this program inside this live session, because it's going to take like 16 minutes or something. And basically the same, both are having the same code. Nothing difference. This is a training data preparation, and this is a test data preparation. And if we are directly getting it from the G drive, this is the code. And this code will actually download the data from the G drive, extract it, and represent it in our our desired format. So it's a very good spot to be in. I kind of ran into a problem here. I shouldn't have done that. I don't know why. Mine is a very yeah. You can see this one for each images. You can see these images. It all belong to the same video ID. The moment you just change into the next frame, change, you can see this one. And that's very good part of this ETL pipeline. I just wrote this code and based on that. So basically, this is the two code that is very important in this code, in this for the ETL pipeline to work. I just add it in the script files inside my project directory, because it's outside the machine learning project. So obviously, it doesn't come inside of, maybe in the future, maybe not. I don't know how it's going to be part of it. I don't know why this is here. Yeah. So basically, this is what happens. And let me explain the template as well. Here's a template of this project. We have the pipelines, which actually combines a lot of pipelines like that, a lot of components like that: ingestion, validation, transformation, training, and all these things into one, and run it. And we just want one of the base pipeline here from the SRC, from the source code. Here's the pipelines. So this is a basic pipeline I just implemented for the data ingestion part. And yeah, that's it. That's how it all works. So far, I haven't done. I just did the ETL pipeline on where I just did the ETL pipeline on the Kaggle. So data ingestion part is mostly about getting the data set from the Kaggle into this into our code. So yeah, and this data ingestion part, we will go to the data ingestion part. You can understand it's taking from the Kaggle, and the Kaggle is a data set, and we just give the details about the data set, and it will output this thing into the directory. And out there we always the out there is always from the config. The config file actually has all the informations about where the data should be saved, what all data sources are there for this project. So there's a data sources as data crash, and the source, data type, and the link to it. In case of Kaggle dataset, it's just about this one. And the artifact dataset will have all the artifacts of this one. For data ingestion, it's the data, so it will have all the information about the data. And you can see it doesn't save that artifact directly, it goes into data, and it actually defines in the data here in this constants, where I just give defines the constant value for data directly in data. So every single data that will happen in this side will actually go in this one, and the models directory will go into the models artifact slash models. And this is a schema directory where schema of the file we are using, schema of the file data set we are using. We will be going to define it in the data validation step. And here the validation, so this will have a schema file called gta crash.yam file. So we can just use those files inside of this one. So for this is the entire ETL pipeline. And this is how the entire data ingestion, data ETL plus data ingestion is all about. Data ingestion is all about data ingestion. Just we changed the we pushed the all these changes. We have made so much changes inside of this script files and a bit more in the, I don't know why didn't it. Yeah, it was it was sent to the GitHub repository, so it's okay for now. So basically, we extract all these informations like the acceleration, and we extract angular velocity into x and y, x, y, and z. And for other informations like forward, v, object size, position, all these things were exploded into x, y, and z. And all these informations were made into a pandas dataset. And we created the video ID based on this format, and we used to use the frame as well. So that's the thing. This is the entire ETL pipeline for this project and data ingestion. In my data ingestion, there will be more data in future, so you cannot say what happens. And that's it for this. That's it for this string.